Hello students, it's me Ms. Faradiba from Peshawar Model School, No.7 branch. Today we will discuss our 7th lecture from class 10 chemistry unit number 9. But before going to discuss our topic, I would like you to subscribe our YouTube channel and don't forget to like and share our videos so you will watch our upcoming videos. Okay, now let's come to our topic. Today the chapter of our class 10 chemistry is chemical equilibrium, and today we will discuss two topics. The first one is society, technology and science, and the other one is the ways to recognize equilibrium. That how we can recognize equilibrium means that whether the equilibrium has been established or not in any reaction. Okay, look at your book here. This first topic is the society, technology and science, and in this topic we will explain that how we can use different atmospheric gases or the components of the atmosphere for the production of different important chemicals. Look at here. Except for helium, which is mostly extracted from natural gas, oxygen, nitrogen and other rare gases are extracted from the air that makes up our atmosphere. Look at here. We know that we can extract the helium from the natural gas, which we can call the methane gas, and we can extract the oxygen, nitrogen and other rare gases from the air that make up our total earth atmosphere. Nitrogen and oxygen are important components of atmosphere. Air is mainly composed of nitrogen, oxygen, carbon dioxide and inert gases. As you can see, nitrogen 78% and oxygen 21% constitute 99% of the atmosphere. By fractional distillation, the air is separated into different fractions. These fractions are used in manufacturing of different chemicals. As you can society, technology and science, and the main point is explain how components of atmosphere can be used successfully in producing important chemicals. In this we will explain that how we can use the atmospheric gases for the production of different chemicals. As you can see in this pie chart, nitrogen is 78.08%, oxygen is 20.9%, and argon is 0.93%, and a lot of different rare gases are present in our atmosphere. So for taking that gases and for using these gases in the production of different chemicals, we will use three processes: the Bricklin ID process, the Hubbards process and the sulfuric acid formation. So we will discuss one by one all of these processes. The first one process is the Bricklin ID process. In this process we will discuss that how two atmospheric gases react and which compound will be which compound we will get at the end. So look at here. Here are the three steps for the production of this nitric acid. In the first step we will use 1 mole of nitrogen and 1 mole of oxygen gas, and we will get 2 moles of nitric oxide. At the second step we will use this nitric oxide, and when this react with the atmospheric oxygen in 1:1 ratio, it will give us 2 moles of nitrogen dioxide. And when this nitrogen dioxide dissolves in water in 3:1 ratio, means 3 moles of nitrogen dioxide and 1 mole of water, we will get 2 mole of nitric acid and 1 mole of nitric oxide. And all of we know that nitric acid is too much important in our chemistry, because we use this nitric acid in different chemical reactions. So on the basis of this we can say that these two atmospheric gases can be used in the production of these important chemicals, which can be used in different chemical reactions. Okay, now look at your book. At your book we can see that after the Bricklin ID process, here is the second process, the Hubbards process, in which nitrogen reacts with the hydrogen and produces ammonia. And all of you know that ammonia acts as a raw material in manufacturing of fertilizers, and it has a lot of different uses in our daily lives. So now we will discuss the Hubbards process. Now look at here the Hubbards process. In the Hubbards process, we will react atmospheric nitrogen with the hydrogen gas, and at the end we will get ammonia gas. As you can see, this nitrogen and hydrogen reaction, this will react with in 1:3 ratio. 1:3 ratio means that we will react 1 mole of nitrogen and 3 mole of hydrogen gas, and at the end we will get 2 moles of ammonia gas. Okay, now when these two gases react in 1:3 ratio, in the presence of iron catalyst and 200 atmospheric pressure and at 400 to 450 degrees Celsius temperature, it will give us the ammonia gas. But when these gases are cooled down, it will give us the liquid ammonia, and a lot of other unreacted gases recycled. Recycled means it will come back and it will react again with the nitrogen and hydrogen, and will start this process again, because recycling means that we will get the starting material and will react again with the different reactants and will start the reaction again. Okay, now we will discuss some of the uses of ammonia. As all of we know that ammonia can be used as a raw material in the production of different fertilizers. It is one of the important component in making fertilizers like urea, and a lot of other fertilizers. We use these fertilizers in our different crops. We can use ammonia in the different explosives like guns, etc. We can use in making nitro based explosive including TNT, RDX, etc. We also use the ammonia in the refrigeration, in the large scale refrigeration plant, or also in the air conditioning units in buildings. All of we know that the air conditioning units which are in the ceilings, like in the buildings which are fixed in the buildings, so for in that air conditioning units we use ammonia gas. The other one is a consumer product. Ammonia is also used in the cleaning as an effective cleaning agents. Likewise, in the Dettol's which are using in the cleaning our roofs or different areas of our homes, and also in using the phenyl. Also in the phenyl we can use ammonia. It can also be used in different pharmas, like it can be used in certain types of drugs such as sulfonamides, anti-malarial drugs, and different vitamins such as thiamine and nicotinamide. And on the basis of this, we can see that we can say that ammonia is too much important in our daily life. The last process is the formation of sulfuric acid, or we also use the term contact process. In this process we will use the atmospheric gas oxygen, and it will react with the sulfur and will give us the sulfuric acid in the 3 steps. In the first steps we will use 1 mole of sulfur and 1 mole of oxygen, and at the end we will get 1 mole of sulfur dioxide. As you can see in this diagram, you can see that when sulfur react with hot air means oxygen gas, it will give us sulfur dioxide in the first step. And in the second step, when sulfur dioxide and oxygen react in 2:1 ratio, means 2 moles of sulfur dioxide and 1 mole of oxygen, it will give us 2 moles of sulfur trioxide. And after that, when sulfur trioxide react with sulfuric acid, it will give us pyrosulfuric acid, or we can use the term oleum for this compound. When this oleum dissolve in water at the last stage, we will get 2 moles of sulfuric acid. As oleum was not the sulfuric acid, so for the production of sulfuric acid, or for getting the sulfuric acid, we use this product, and when it dissolve in water, it will give us the sulfuric acid. And all of we know that sulfuric acid has a lot of different uses in our chemical industry, and all of we know that sulfuric acid has been known as the king of acids. Now look at your book. The second one topic is the ways to recognize equilibrium. In order to recognize equilibrium state of chemical reaction, the following methods can be used. The first one is a physical method and the other one is chemical method. In your book here are mentioned only the names of these methods, but we will discuss a little bit info for your easiness. So now look at this. Here are two methods. The first one is physical method. In physical method there are three terminologies which we will discuss a little bit. The first one is reflectometry, the other one is polarimetry and spectrophotometry. And in chemical methods there is the titration, which is the chemical process. The first one, a process, is the reflectometry, which is the physical method, and in this method we will determine the concentration, the composition or the purity of a solution. Look at here is a light source, a prism, and on the top of the prism here is the sample of which we can find their purity. On the prism there would be the refraction of that sample, so we can find out the purity of that substances or that samples by the refraction of light, that how much light is reflected from that sample. So on the basis of that reflection, or we can say the refractive index, which is the scale of the measurement of the refraction of that light. So on the basis of that refractive index we can use or we can characterize the liquid and the solid samples and their purities. And the instrument of by which we can find the refractive index, or we can say the concentration of any solution, is called the reflectometry, and through this we can find the refractive index or the concentration, the composition or the purity of any substances which are under observation or which we has taken in that system. Okay, the next one is now the second one is polarimetry. This is the process by which we can find the optical activity of any substance, that whether that would be organic or inorganic. The substances or the compounds would be optically active if we see the polarized light rotate after passing through the prism. Look at this diagram. Here is a source of light and here is a polarimeter. It means that if the light passes through any substance or any sample solution, and if that rotate, whether that rotation will be clockwise or anti-clockwise, so that would be optically active. It means that if the polarized light rotate after passing through the prism, that would be optically active. So on the basis of their optical activity we can find the concentration of any substance or the purity of any substance. Means that a molecule would be concentrated if the optical activity or the number of rotations would be higher, and if that substance would be not pure, the optical activity will be less than that. So on the basis of this we can find out the concentration and the composition of any solution. Now the next one is spectrophotometry. What is spectrophotometry? A method in which we can measure an amount of light that the sample absorbs. It means that through this process we can find the absorbance or transmission of any sample solution. It means that through this process we can find out the purity of any substance. If the transmission is higher, it means that substance would be pure, means that a sample solution absorbs too much light and will give us the higher voltage. Look at this diagram. It is spectrophotometer, an instrument through which we can measure the intensity of light, or we can say the absorbance or transmission of light of any solution would be called the spectrophotometer. Spectrophotometer consists of two instruments, the spectrometer and the photometer. Spectrometer is to produce light of any wavelength and photometer is to measure the voltage of that solution. Spectrophotometer is designed in a way that the cuvette has been placed between the spectrometer and the photometer. Cuvette is the place where we can put the sample solution. and the photometer is to detect the light of any wavelength and will give us the voltage on the display. Look at this output area where we can find the voltage of any wavelength. So if the intensity of the light has been changed, automatically the voltage will also be changed. The spectrophotometer consists of the light source, the monochromator, or we can say the spectrometer, an adjustable aperture, a cuvette. Cuvette is the place where we can put the sample solution, a photometer through which we can detect or we can measure the voltage of any sample solution, and the output display where we can find the voltage of any solution. This instrument can be used in measuring color and used for measuring color accuracy. Means through this process we can measure the color accuracy, that which color has been produced by which substance or by which sample solution. It finds its major application in liquids, plastics, papers, and also in fabrics. Now look at see the uses of spectrophotometer. Spectrophotometer is used to determine the absorbance and transmission of characterized wavelength of radiant energy by chemical species in a solution. It means that it shows the absorbance or transmission of any chemical species which is present in a solution. So if if in the solution there has been two or more reactants, so by their colors we can find out that which spectrum has been produced by which substance. Identify organic compounds by identifying absorption maximum. It means that we can characterize organic compound by their absorption maximum. Used for color determination within the spectral range. It means that in one spectrum there has been many colors, and we can find out the organic compound by their color determination. It means that one substance will produce one color and the other will be other. So by that we can find out their classification, or we can characterize that organic compounds. Okay, the next one is chemical method. In chemical method there is a titration. What is titration? It is a technique where a solution of known concentration is used to determine the concentration of an unknown solution. It means that here are burette. This is a titration flask, and in both of these apparatus we will put the solution of known and unknown solutions. Here are two basic types of titration: the qualitative analysis and the quantitative analysis. Qualitative analysis means we will find out the purity of a concentration of any substance, and in quantitative analysis we will find out the concentration, the molarity, etc. Okay, now look at here. This is a burette. In this burette we will put the solution of any known substance, and this is titration flask. In this titration flask we will put the solution of any unknown substance, and indicator will also be used in this titration flask, and due to this indicator the color will be pink. So if when the reaction starts, so this solution of or we can say the known solution which is present in the burette will become drop wise in this titration flask, and at the end of the reaction, when the color of this solution in the titration flask disappears, or if the color if this pink color become colorless, so it means that would be the end point of any chemical reaction, and on that point we can find out the molarity of that solution. So on the basis of that we can find out the purity of that substance, that how much that solution has been pure, or we can find out the concentration of this unknown substance which is present in this titration flask. Okay, now look at your book. In your book, in both methods physical and chemical processes. The equilibrium state of chemical reaction can be recognized by knowing the concentration of reactants and products at regular intervals of time. It means through this both of these processes we can find out the equilibrium state, that whether that has been established or not, by knowing the concentration of reactants and products time to time, that how much that would be changing time to time. And when the concentration of reactants and products are observed constant, then the reaction is said to be in equilibrium state. And when it comes at constant, it means there has been established the equilibrium state. Okay, that was all about the physical and chemical processes, and also the science, technology and society. And if you have any questions, so you can ask me in the comment section. Okay, thank you so much, students.